Hello, now let us solve the problem together. The first thing that I want to remind you is just the formula for the double angle for sine 2x. So the formula is this. So sine 2x is equal to 2 sine x cosine x. So that's the formula that I want to use for the numerator. For the denominator, what I do, I decompose this 3 to 1 plus 2, okay? So the denominator can be written as, so let me write den for the denominator, is equal to, I can write 1 plus 2 plus 2 sine x minus cosine x squared. Now, if I take this 1 and this minus cosine x squared, I will get a sine x squared, yes? So this becomes sine x squared plus 2 sine x, and then 2 is left for me here. I can continue a little bit, so I can write it as sine x plus 1 squared, and then plus 2, plus 1. Why is that? So let me expand this one. The first one squared will give me this term. 2 times the first one times the second one will give me this middle term. Then I will have 1 squared and another 1 here, so I will get my 2 back. So what I have done is completely correct. So then I go to the question mark here. This is equal to the integral from 0 to pi over 2. In the numerator, I write 2 sine x d cosine x. And in the denominator, I just write sine x plus 1 squared plus 1. And then I have my dx here. Now I introduce a new variable here. I would say that let u be equal to sine x plus 1. I differentiate both sides, then I get du is equal to the derivative of sine is cosine x, then I will have dx. That's good, because then this part that you see here is just simply du. And this one is also u. The only problem is that I need to write sine x also in terms of u. So this motivates me to go back, and from here I calculate sine x to be u minus 1. The next thing that I have to consider are what happens to my limits. 0 and pi over 2 are limits for the x variable. I want the limits for my new variable u. Okay, so what do? I would say that x is going from 0 to pi over 2. This implies that u goes from, if I put 0 for x here, u becomes sine of 0 plus 1. Sine of 0 is 0, so it becomes 1. If I put pi over 2 here, sine of pi over 2 is 1. 1 plus 1 is 2, so the upper limit becomes actually 2. So now everything is ready. I go back to my question mark. So the answer is integral. Instead of going from 0 to pi over 2, I go from 1 to 2. And then I have 2 in the numerator. Instead of sine x, I write u minus 1. Instead of cosine x dx, I write du. And instead of sine x plus 1, I just write u. U squared plus 1 du. Okay, so what I do, I will try to decompose this fraction into 2 fractions. So let me just multiply 2 in. So this becomes 2u minus 2 divided by u squared plus 1 du from 1 to 2. And I decompose this integral into 2 parts. So this becomes integral from 1 to 2, 2u over u squared plus 1 du minus, I pull 2 out, integral from 1 to 2 du over u squared plus 1. So what I have done, I have taken this part and that part separately. In one of them I didn't pull 2 out, in the other one I pulled 2 out. The reason is clear, because in this integral, what I want to do, I have to introduce a new variable. So I would say that let us take u squared plus 1 to be a new variable t, then differentiating both sides, so this becomes 2u du is just dt, and then u goes from 1 to 2. This would then imply that my new variable t goes from 2 to 5, yes? Because when u is 1, I put it here, then I get t is 2. When u is 2, I put it here, t is 5. So this integral becomes equal to integral from 2 to 5. In the numerator, you see that 2u du is just dt. And in the denominator, I have t. So this becomes ln of absolute value of t from 2 to 5. So this becomes ln of 5 minus ln of 2, which can be written as ln of 5 over 2. So that is the answer to the first part. For the second part, let me remind you of another formula. So if we have integral of dx over x squared plus a squared, of course if a is positive, then the answer to this is a very famous integral. So this becomes 1 over a arctangent of x over a plus, of course, a constant c. So if you compare this formula with what we have here, u here is playing the role of x, and then 1 can be imagined as 1 squared, so a is being played by 1. So a is actually 1 in this problem. So what I want to do, so this integral part is equal to 1 over a, which is 1, and then I have arctangent of x, which in this case is u over a is 1, arctangent of u goes from 1 to 2, which becomes arctangent of 2 minus arctangent of 1. Arctangent of 1 is simply pi over 4. Okay, so now I combine the results that I have got so far, so then I will have my question mark. So the question mark will be equal to this first part is ln of 5 over 2, and then minus 2 times what I got here. So if I multiply minus 2 in, it becomes negative 2 arctangent of 2, but positive pi over 2. So that will be the answer to this integral. Okay, I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.